So from a bird's angle view, right? So from the top view, there are two types of segregations in the probability distribution. So what when we use word distributions, we generally mean is some function that can define the data. So that's the simplest of the definition of a probability distributions, that some function that defines the data or probability of getting some data. Before we move on, right, I forgot this. So in R, what D before any distribution, what does this mean? It will return the density function or height of the probability density function. Okay, so if you let's say this is the normal distribution, right? And this is from, let's say, -10 to +10 with the mean of 0. What is the y-axis? Y-axis is just the probability. That's how the PDF you define, right? Now the D, what D would return is the height of this thing. Okay. P return is the cumulative density function. So P would return everything before that. So this whole would be returned, or area under this curve would be returned by the P value. If you want to Q, quantile is just the inverse of this. So if I say how much area is 0.25 till what value, so this would be the quantile, Q value. Okay. Just for randomly generation of the numbers. Everyone understood this? So simple example would be, if I say normal 0-1 distribution, if I say at 0, tell me what is D value, D binomial. If I do, then it would return me 0.5. That is the probability, right? Or what is the probability? If I say the P value, it will not return 0.5, sorry. If I say the P value, it would return me the area of this curve. What would the Q value? Q value I have to specify for to cover 0.5 area. What is the value? That is till 0. So that's how the notations, that's where the hypothesis testing comes into. Another example would be, if I do a blind test, right? So can people, like in a blindfold, let's say, taste the difference between some brand of whiskey, single malt or blended whiskey? Can they tell the difference between the two, right? Or this is a famous example for, let's say, take example, people are blindfolded and you are testing for Coke and Thumbs Up or Coke and Pepsi, whether they can tell the difference between Coke and Pepsi, right? So let's say we did this experiment. We took 10 people. 7 can correctly identify their drink and 3 couldn't. Can you tell that, okay, with blind, like, yes, we can correctly identify the difference between the two? No, right? Because it's only 10 people. But if we repeat this experiment with 1,000 people, then you will say that, yes, exactly, this is more significant. Now, the thing is, the ratio remains same. For 10, it was 7 and 3, right? So 0.3 and 0.7. For 1000 also, it was 0.3 and 0.7. But the statistical significance for 1000 is more than the 1000 people's, yes, you can tell the difference. Where hypothesis testing comes into picture. So what we do is that, to do this, we assume a null hypothesis. We say that, okay, we would assume, let's say, null hypothesis is people can't tell the difference, and then we do the experiment. If the probability is very low, then we say that, okay, there is something and this is not, right? So for example, for 10 people, right? So for 10, now to get that hypothesis is you can't tell the difference. So if you can't tell the difference, then the probability is 0.5, right? So out of 10 experiments, you get 7 as correct and 3 as incorrect, right? So what is the probability of that? So you get that probability as 7, 8, 9, 10, and then you get 0.717 probability. You'd say that okay, this is not that significant difference. I mean, with 20% probability, you can get this from a probably you can get this from randomness. That's what hypothesis testing is all about. A famous example I would say is in retail industry when you want to segment your customers, right? So I personally used it for uh, segmenting of the customers or retail customers, right? So you can segment it. The most particular segmentation that you can do is RFM. So RFM is segmentation, kind of segmentation, which gives a sense that recency, frequency, and monetary value, right? So most recent transaction, then frequent transactions and monetary aspect. So who would be your most valuable customers, best customers? What would you define those customers? So you understand recency, right? So recency is how recent the transaction has been made by a particular customer. So for example, if I made a transaction just last week from today, if I say just last week I made a transaction, so my recency would be 7 days. If someone, so um, let's say someone made a transaction, probably Shefali made a transaction about a month ago, so her recency would be 30 days. Anish might have made a transaction 2 months ago, so your recency would be around 60 days, right? So from today's date, how recent the transaction is. Frequency, so in my lifetime, right, in the whole lifetime, how many transactions I have done so far, so that gives me frequency. So I have done probably 100 transactions, Shefali might have done 50 transactions, Anish might have done only 10 transactions, right? So those give me frequency. Then there is a monetary value, so I might have done only 500 rupee transactions, although I have done 100 transactions but only 500. Shefali might have done transactions of around, let's say, 1,000 rupees. Anish might have done transactions of 100 rupees, right? So that is monetary. So these three variables you take and you apply clustering on this. So what is the different types of clusters you would get? You get a cluster. The most valuable cluster would be that is having high recency, that is having highest frequency, and that is having highest monetary value.
So I have a doubt.
Yeah,
So in monetary value, are we supposed to take the average transaction value of that customer or lifetime value?
I mean that depends on you. So that's where your thought process or your understanding of the business would come into, right? So generally we take all the sum of the value, right? So because there's no point to average. Why there's no point to average? Because you are already considering the frequency factor into your clustering, right? The frequency would take care of that. If you give it an average, so for average you will divide the amount by frequency, right? So that will not make more sense because you already took a frequency variable into your account.
So,
So
but
just
isn't it very likely that someone who has been frequently visiting has a higher lifetime value?
no, it's not. So that's what when you do a clustering, right? So you will see that when there are few customers who frequently visits your store, but they do only small amount of transactions. But there are few customers who visits after some time, but they do a bulk of the transactions, right? So for example, let's say from grocery store point, every customer has a different frequency, right? So let's say I do a grocery after 2 months, but I do it in bulk. Someone comes after every 2 3 days to you, but they do like okay, this much, only small amount of transactions, right? So that's where the clustering algorithm will segregate these two clusters apart based on the frequency. Although the monetary value will be almost similar for those two, but it would segregate those two customers for a frequency. Got it? So this is
Actually, I still have a little doubt here. So
yeah.
like, basically, our lifetime value would be nothing but the frequency into the uh, average transaction value, right? Like number of
Exactly.
transactions. So, sir, in that last monetary value factor itself, we are all again taking the frequency, right, into consideration.
Uh,
Um, so,
might
isn't
not take. So uh, let's say I have a Flipkart. I'm doing analysis of Flipkart, right? And there are customers who buy mobiles. They have done it for only 2 times. So what would be like 2 times they have bought a mobile? So their lifetime spend is around 60,000, right? With the frequency of 2. There's another customer who hasn't bought mobiles but small items from the Flipkart. Probably let's say from Flipkart they have bought something from home or kitchen supplies. So they might have done how many 10 or 20 transactions to reach that 60,000, right?
correct?
Right now, in terms of a lifetime value, if I say lifetime value for both is probably 60,000,
Hmm.
right? But in terms of frequency, they are very different. So the clustering would segregate them on the frequency value. If I give them an average value, one would be of like it might take that into consideration, but we don't want to like interdependent variables in the clustering.
Okay, sir. Yeah.
Got it? So because when you see this dimensions, right? So the clustering is nothing but a independent dimensions. One is X, one is Y, one is Z. This should be independent across, right? So you don't want the dependent definition Y is equal to something X upon Y or something, right? So that should not happen. So 3 independent dimensions and cluster on that part.
Okay, sir. Yeah.
Now this is Euclidean distance, then we can have Manhattan distance or Mahalanobis distance. Those are the different distance notions that we can have. Right.